Hey everyone, ever had a piece of tech just die on you for no reason? Imagine that, but concentrated in one specific spot. A place where it happens not just to you, but to everyone. Every time. And nobody, not even the best engineers, can figure out why. What do you think could possibly cause something like that? Have you ever heard of anything remotely similar? Let me tell you about the Oakhaven Bridge. It's a perfectly ordinary-looking span, concrete and steel, crossing the placid waters of Willow Creek, just outside the small, unassuming town of Havenwood. For decades, it was just part of the daily commute, a backdrop to countless drives, runs, and bike rides. Then, subtly at first, things started to get weird. It wasn't a sudden, dramatic event. No blinding flash, no strange sounds. It began with isolated incidents, easy to dismiss. A car engine momentarily sputtering only when crossing the bridge. A smartphone freezing or shutting down right in the middle of a call, only to spring back to life once safely on the other side. GPS units losing signal or giving completely nonsensical directions specifically within the bridge's short span. People chalked it up to faulty devices, sunspots, maybe just bad luck. Early complaints were scattered. A post on a local online forum about a car's dashboard lights flickering. A comment under a news article about signal dropouts in the area. "My phone always dies crossing the Oakhaven Bridge," one user would write. Another might reply, "Mine too. Thought it was just old." It was the digital equivalent of a local legend, a minor annoyance discussed in hushed tones at the grocery store or over coffee. But the anecdotes piled up. Too many people experiencing similar specific failures consistently linked to this one relatively short bridge. It wasn't just phones anymore. Bluetooth connections would drop. Smartwatches would reset. Key fobs would fail to unlock car doors immediately before or after crossing. The sheer volume and consistency of the reports started to become undeniable, moving from the realm of quirky coincidence to something genuinely perplexing. It felt like the bridge itself was hostile to modern technology. Drivers reported their radio losing station completely, not just static, but just silence. Dash cams would inexplicably stop recording. Cyclists using cycling computers noticed their data corrupted or the device powered off as they pedaled across. What was once a handful of scattered, easily dismissed complaints began to coalesce into a pattern that couldn't be ignored. Local mechanics started hearing recurring stories from customers whose cars had momentary electrical glitches that they could only attribute to driving over the Oakhaven Bridge. They'd check the car's systems, run diagnostics. Nothing. No error code stored, no loose wires, no failing components. The cars were fine, except, apparently, when traversing that one specific 100-meter stretch of road. The phenomenon seemed to be strictly confined to the bridge structure itself and its immediate approaches, maybe 50 feet on either side. Step off the bridge, and the device would often miraculously recover, sometimes instantly, sometimes after a manual restart. It was as if the bridge was an invisible temporary dead zone for complex electronics. The sheer ordinariness of the bridge made it all the more unsettling. It wasn't near any high-tension power lines that could explain electromagnetic interference. It wasn't over any known geological oddity emitting strange fields. It was just concrete, asphalt, steel rebar, and water below. And yet, it was acting like a digital Bermuda Triangle. As these stories spread, people started experimenting, cautiously. Some drivers would deliberately try crossing with different phones, different cars. The result was almost always the same. Whatever electronic device was active experienced some form of disruption or failure. It didn't discriminate by brand, operating system, or age of the device. A brand new iPhone would die just as readily as an older Android. A cutting-edge electric vehicle's sophisticated electronics would glitch alongside an older car's simpler computer. This ruled out individual device defects as the primary cause. The focus shifted firmly to the location itself, the Oakhaven Bridge. The local newspaper, the Havenwood Gazette, initially ran a small human interest piece titled "Our Own Little Mystery Spot," which chronicled some of the stranger tales. The response was overwhelming. The comments section and letters to the editor were flooded with people sharing their own experiences, many expressing relief that they weren't alone or imagining things. One woman described her car's navigation system completely wiping its planned route every time she crossed, forcing her to pull over on the other side to re-enter it. A delivery driver complained he had to stop relying on his truck's built-in GPS and revert to a paper map for deliveries involving crossing the bridge. The collective weight of these testimonies grew too heavy to ignore. It wasn't just a few isolated incidents. It was a consistent, repeatable phenomenon affecting a wide range of electronic devices. The casual curiosity began to turn into genuine concern, and a demand for an explanation started to build within the community. What was happening on the Oakhaven Bridge? And why was it specifically targeting electronics? Was it dangerous? Could it affect medical devices? These questions, initially whispered, began to be asked more loudly, pushing the mystery from a local oddity into something requiring serious attention. The anecdotal evidence was compelling, but it lacked scientific rigor. Engineers, hearing the buzz, initially remained skeptical. They expected a simple explanation, perhaps interference from amateur radio operators, faulty wiring on the bridge itself, though it wasn't electrified in any obvious way, or even mass hysteria fueled by social media. They needed data, measurements, controlled observations, not just stories about dead phones and sputtering engines. But getting those measurements proved to be the first major hurdle in understanding the enigma of the Oakhaven Bridge. The local authorities, prodded by the increasing volume of complaints and the minor traffic disruptions caused by cars momentarily stalling or drivers fumbling with suddenly defunct GPS units, decided it was time for a more official look. The town engineer's office, a small team usually occupied with road maintenance and water pipes, was tasked with the initial assessment. Armed with standard electronic testing equipment, multimeters, basic signal strength meters, handheld GPS units, and a couple of borrowed oscilloscopes, they approached the bridge with a mix of skepticism and mild curiosity. Their first few passes across the bridge yielded confusing results. Sometimes their GPS unit would freeze, sometimes it wouldn't. A handheld radio scanner they brought showed no unusual signals. A multimeter attached to a simple circuit seemed unaffected. "See?" said Mark Jenkins, the senior town engineer, to his younger colleague, Emily Carter. "Probably just mass panic, or maybe some weird localized signal that pops up randomly." But then Emily's company smartphone, relatively new, suddenly displayed a distorted screen and shut off completely as they drove back over. It wouldn't turn back on until they were a good distance away from the bridge. And even then, it required a hard reset. Mark's older flip phone remained working, though he admitted the call he was on got strangely garbled for a few seconds mid-span. They tried crossing on foot, carrying various gadgets. A digital camera refused to power on while standing precisely at the bridge's midpoint. A portable weather station with a digital display went blank. They started noticing a pattern the earlier reports hinted at. Simpler electronics seemed less affected, while more complex, digitally driven devices were prone to failure. An old-fashioned car with minimal electronics might just have a radio crackle, while a modern vehicle with dozens of embedded computers would experience engine hesitations or dashboard failures. This pointed away from a simple, broad electromagnetic pulse that would fry everything indiscriminately and towards something more nuanced, something that perhaps disrupted digital signals or low-voltage control systems. The town engineer's investigation, though limited in scope and equipment, confirmed that something was definitely happening, and it wasn't easily explainable by standard interference sources they could measure with their basic tools. Their report, cautiously worded, stated that while no conventional source of interference or electrical fault was found on the bridge structure itself, reproducible malfunctions of various electronic devices were observed within the bridge's footprint. This official acknowledgement, however preliminary, elevated the issue. It wasn't just anecdotal anymore. The town's own engineers had witnessed and documented the failures. The Havenwood Gazette ran a follow-up story, this time with a more serious tone, quoting Mark Jenkins about their inconclusive findings. This attracted the attention of regional news outlets, and the story of the Oakhaven Bridge, the place where electronics die, began to spread beyond the local area. Universities in the state, particularly those with strong engineering or physics departments, took notice. The mystery was scientifically intriguing. A team from the State University's Electrical Engineering Department, led by Dr. Anya Sharma, a specialist in electromagnetic fields and signal integrity, decided to mount a more thorough investigation. Unlike the town engineers, Dr. Sharma's team arrived with serious equipment: professional-grade spectrum analyzers, high-sensitivity magnetometers, oscilloscopes capable of detecting transient signals, specialized antennas, shielded data loggers, and a collection of various test devices ranging from basic calculators to complex single-board computers. Their plan was systematic: measure all known forms of radiation, electromagnetic, radio waves, magnetic fields, across and around the bridge, while simultaneously testing a suite of electronic devices under controlled conditions. They set up a temporary base camp near the bridge, rigging up instruments to run continuous monitoring. The initial excitement of tackling a real-world scientific mystery quickly gave way to frustration. Their sophisticated spectrum analyzers, designed to detect faint signals across a wide range of frequencies, would often display corrupted data or simply freeze when brought onto the bridge. Their sensitive magnetometers sometimes showed bizarre, nonsensical readings or flat-lined. Even their robust, shielded data loggers, intended to record measurements under any conditions, proved vulnerable, sometimes failing to power on or recording garbled information. It was like the bridge itself was actively interfering with their ability to measure the interference. They had to develop workarounds, placing equipment at the edge of the anomaly's presumed zone and using cables to extend sensors into the affected area, hoping the equipment itself, located just off the bridge, wouldn't be impacted. But even this wasn't foolproof. The phenomenon seemed to have a subtle boundary that wasn't a sharp line, and sometimes the effects would reach out and disrupt their base equipment. The consistent failure of their own high-quality scientific-grade electronics was profoundly unsettling. These weren't cheap consumer gadgets. They were designed to be reliable and resistant to environmental noise. Yet the Oakhaven Bridge seemed capable of disabling them. This wasn't just interference. It felt like an active disruption of the very principles by which these devices operated. The sheer difficulty in measuring the anomaly became part of the anomaly itself. It was a scientific paradox. How do you study something that breaks your tools every time you try to study it directly? The team was forced back to the drawing board, trying to devise experiments using analog instruments where possible, or using digital tools in ways that minimized their exposure or reliance on real-time processing. But the mystery only deepened. Dr. Sharma's team, hampered by the bridge's apparent hostility to their primary tools, had to get creative. They tried setting up arrays of simpler analog sensors slightly off the bridge's structure, hoping to triangulate or detect something radiating from the area. They used old-school compasses, simple radio receivers with analog dials, even photographic film, though this was more speculative, looking for any unknown radiation affecting emulsion. These analog tools, for the most part, remained functional. The compass needles pointed north. The radio receivers picked up distant stations, though sometimes with unusual static or fading when pointing directly towards the bridge. And the film remained unaffected. This reinforced the idea that the phenomenon was specifically targeting electronics, particularly those relying on complex digital processing or sensitive low-voltage circuitry, rather than a broad physical force like intense magnetism or ionizing radiation that would affect matter or basic electrical flow indiscriminately. They hypothesized it might be a highly localized, perhaps pulsed, electromagnetic field within a very specific frequency range, or perhaps a complex combination of fields that resonated with the operating frequencies or clock speeds of modern electronics. But their attempts to detect such a field directly with their sophisticated spectrum analyzers were still failing. They tried bringing in older electronic devices, things from the 1970s or 80s with minimal microprocessors and more analog components. An old Walkman played tapes fine, though sometimes with strange fluctuations in speed. An older car, pre-1990s, with mechanical fuel injection and simpler ignition systems, could cross with only minor radio crackle, if any, its engine running smoothly. This further supported the idea that the complexity and digital nature of modern electronics was key to their vulnerability. It wasn't just electricity being interrupted. It was the specific way modern devices used electricity to process information that was being targeted or disrupted. The team considered geological factors again. While initial surveys found nothing unusual, they brought in geophysicists with more specialized equipment, including ground-penetrating radar and seismic sensors. Again, the results were frustratingly normal. No unusual rock formations, no signs of subterranean water flows that could generate telluric currents, no evidence of unusual mineral deposits that might create localized magnetic anomalies. Even if there were geological factors, how could they selectively target electronics based on their digital complexity? It didn't fit any known physics. Another hypothesis was something related to resonance. Could the bridge structure itself, or something within it, be resonating at frequencies that disrupted electronic components? Engineers examined the bridge's blueprints, its construction materials, looking for anything unusual. It was a standard reinforced concrete bridge, built in the 1950s. Nothing in its design or materials screamed mystery anomaly generator. They even considered external sources they might have initially missed. A hidden military experiment, secret communication arrays, something truly exotic. But extensive surveys of the surrounding area, using airborne sensors and ground teams, turned up nothing of the sort. There were no unusual power sources, no strange antenna farms, no secured facilities that could be the source. The phenomenon was centered on the bridge and vanished relatively quickly outside its bounds. Dr. Sharma's team published their preliminary findings in a scientific journal, outlining the observed phenomenon, the failed attempts at measurement, and the ruling out of conventional explanations. The paper generated significant buzz within the scientific community, not because they had found an answer, but precisely because they hadn't. It was a well-documented account of a phenomenon that defied easy categorization within known physics and engineering principles. They described the effects in detail: devices losing power, data corruption, screen distortions, loss of connectivity, even temporary software glitches that required a hard reset to resolve. They noted the variance. Some crossings resulted in total device shutdown, others just minor glitches, and occasionally, though rarely, a device might seem unaffected. There was no clear pattern based on weather, time of day, or traffic volume. This unpredictability added another layer of complexity to an already baffling problem. Was the source intermittent? Was the interaction sensitive to tiny variations? The lack of a consistent, measurable physical output from the bridge, no detectable strong EM field, no radiation, no unusual magnetic anomaly that correlated with the electronic failures, was perhaps the most baffling aspect. It was as if the bridge wasn't emitting something detectable by their sensors, but rather doing something that disrupted the internal workings of electronics directly. The possibility of it being related to quantum effects or unknown physics was floated, albeit cautiously, in hushed tones among the researchers, highlighting the depth of their bewilderment. The Oakhaven Bridge had become a real-world enigma, a concrete structure challenging the fundamental understanding of how electronics interact with their environment. While the scientists puzzled over the invisible forces at play, the residents of Havenwood and the surrounding area had to live with the reality of the Oakhaven Bridge's strange properties. The initial curiosity and mild annoyance gave way to practical adjustments and a simmering undercurrent of unease. Crossing the bridge became a deliberate act, requiring preparation. Drivers developed rituals. Turn off your phone, unplug your GPS, disconnect Bluetooth devices before you get near the bridge. Some even claimed turning off their car's infotainment system helped, though engineers were skeptical that would make a difference to the engine control unit. People reverted to analog maps if they needed navigation involving the bridge. Delivery companies rerouted their drivers, adding significant time and cost to deliveries that would normally use the bridge. Businesses on the other side of the creek from Havenwood saw a drop in casual visitors who didn't want to deal with the hassle or the risk to their car's electronics. The economic impact, though localized, was real. The town considered building a new bridge, but the cost was prohibitive, and there was no guarantee the phenomenon wouldn't extend to a new structure built in the same location or using the same materials. Plus, understanding why it happened seemed crucial before simply building around it. What if the problem wasn't the bridge, but something inherent to the ground beneath it? For some residents, the mystery fueled speculation that bordered on superstition. Whispers of old legends about the land, theories involving secret government projects, even outlandish ideas about extraterrestrial influence began to circulate, mostly online or in local forums. While most dismissed these as fantasy, they reflected the community's struggle to make sense of something entirely outside their normal experience. The official investigation by Dr. Sharma's team, while yielding no answers, at least demonstrated that the authorities were taking it seriously. However, the lack of progress was demoralizing. The initial surge of scientific interest started to wane as funding for inconclusive research became harder to justify. The Oakhaven Bridge wasn't causing major accidents. Most drivers were cautious and expected problems. And it wasn't an immediate threat to life, unless perhaps you relied on a pacemaker. A terrifying thought that thankfully hadn't manifested in any reported incidents, but added to the background anxiety. It was just there, a persistent, inconvenient, and baffling anomaly. Signs were eventually posted on the approaches to the bridge, simple yellow warning signs with symbols indicating failing electronic devices, a crossed-out phone, a flickering car dashboard. They were a stark, official acknowledgement of the unexplainable problem. For the younger generation, the Oakhaven Bridge became a local legend, a place to test the limits of the weird. Teenagers would sometimes drive across, deliberately trying to film their phone's screen as it went black, posting the videos online. It was a bizarre, modern-day ritual, but for the older or less technologically savvy residents, it remained a source of anxiety. What if their car stalled completely in the middle of crossing? What if they had an emergency and their phone failed? The bridge forced people to rely on older methods, to think analog in a digital world. It was a constant, tangible reminder that despite all the advancements of science and technology, there were still phenomena that completely eluded understanding. The engineers' continued inability to provide an explanation only amplified this feeling of helplessness. They could describe what was happening. Electronics failing, but not how or why. They could rule out known causes, no detectable EM source, no geological anomaly, no structural issue, but couldn't propose an unknown one that fit the observations. The bridge stood as a silent, concrete challenge to scientific knowledge, a daily obstacle that had become woven into the fabric of life in Havenwood, forcing people to adapt to a reality where technology wasn't always reliable, especially not on that one particular stretch of road. The initial phase of intense investigation gave way to a period of sustained, but less intense monitoring. The state university team, their initial grant money depleted and no breakthrough in sight, had to scale back their operations significantly. They left behind some automated monitoring equipment, sensors designed to detect subtle changes in magnetic fields, ambient radio frequencies, and possibly even seismic activity. But these were placed near the bridge, not on it, to minimize the risk of the bridge's effect disabling them. The data they collected was voluminous but frustratingly inconclusive. There were fluctuations in various readings, but nothing that clearly correlated with the times people reported electronic failures. The phenomenon seemed to be inconsistent in its strength or manifestation. Or perhaps the automated sensors simply weren't detecting the right kind of energy or disruption. The bridge where all electronics die remained a puzzle with no pieces fitting together. Various independent researchers and hobbyists, intrigued by the published findings and the ongoing mystery, attempted their own investigations. Some tried using Faraday cages, enclosing devices in conductive mesh, hypothesizing it was an electromagnetic field. While a perfectly constructed, grounded Faraday cage should block external EM fields, building one large enough to enclose a car or even a pedestrian, and ensuring it's perfectly effective is incredibly difficult outside a laboratory. Anecdotal reports from these attempts were mixed. Some claimed their devices survived crossings in makeshift shielding. Others said it made no difference. This further muddled the data. Was the shielding ineffective, or was the phenomenon not purely electromagnetic? Other theories emerged from the fringes. Infrasound causing components to vibrate, unknown particles disrupting silicon, even stranger ideas about space-time distortions. None of these gained traction within the mainstream scientific community due to lack of evidence and the seemingly specific effect on functioning electronics rather than passive matter or simple electrical flow. The engineers were stuck. They had performed extensive tests. Electromagnetic spectrum analysis, scanned frequencies from ELF to gigahertz, found only expected ambient noise, radio stations, Wi-Fi, etc. No unusual strong emitters. Magnetic field measurement, used sensitive magnetometers, detected Earth's magnetic field and minor local variations expected from rebar in concrete, but no intense or fluctuating magnetic fields that correlated with failures. Radioactivity testing. Checked for ionizing radiation. Levels were normal background radiation. Structural integrity. Inspected the bridge for hidden wiring, pipes, or unusual materials. Found nothing out of the ordinary for its construction era. Geological survey. Examined bedrock, soil composition, potential water flows beneath. revealed typical local geology, no known anomalies. Controlled device testing. Repeatedly took various operational electronics, phones, laptops, cameras, microcontrollers, simple circuit boards across the bridge. Documented the types of failures, crashes, shutdowns, data corruption, malfunctions, but could not consistently predict when or which device would be affected on any given pass, only that some failure was highly likely. The sheer inability to isolate a measurable cause was the central problem. It violated fundamental principles of scientific investigation. Observe, hypothesize, test, measure. They could observe the effect, but they couldn't measure the cause, and therefore couldn't effectively test hypotheses based on known physics. The most frustrating aspect for the engineers was the lack of a clear signature. An intense radio wave would show up on a spectrum analyzer. A strong magnetic field would register on a magnetometer. A power surge would fry components or trigger protective circuits. The Oakhaven Bridge phenomenon seemed to bypass these expected interactions, acting more like a subtle disruption of the informational or processing state of the electronics. It was like a phantom force that specifically targeted the integrated circuits and software that made modern devices smart. The idea that it might be interacting with electronics at a level more fundamental than macroscopic fields, perhaps affecting electron flow within semiconductors or disrupting quantum states, was discussed. But these were speculative avenues requiring entirely new methods of detection. Methods that likely would also be affected by the very phenomenon they were trying to measure. The bridge became a real-world case study in the limits of current scientific understanding and technological capability. It wasn't just a local mystery anymore. It was a known anomaly within certain scientific circles, discussed in niche forums and at conferences as an unsolved problem, a challenge to conventional physics and engineering. The official investigation was effectively stalled, pending either the development of entirely new detection technologies or the accidental discovery of a crucial missing piece of information. Meanwhile, the yellow warning signs remained, a constant reminder to those crossing to expect the unexpected and to disconnect from their digital lives for a few moments over the Willow Creek. Life in Havenwood adapted, but the underlying question persisted, hanging in the air like the unexplained force itself. What is happening on the Oakhaven Bridge? And if we can't even measure it, how could we ever hope to understand or mitigate it? The bridge continued its silent, invisible assault on microprocessors, a concrete monument to a modern mystery that engineers, for all their knowledge and tools, simply could not explain. The Oakhaven Bridge continues to stand, a mundane structure masking an extraordinary, unyielding puzzle. Years have passed since the initial flurry of reports and the subsequent, ultimately stalled investigations. For the residents of Havenwood, the anomaly has become a part of life, an accepted oddity they navigate daily. The rituals of preparing to cross, turning off phones, unplugging devices, are second nature. The yellow warning signs have faded slightly under the sun and rain, but their message remains clear and necessary. The minor economic impact persists. Businesses relying on through traffic or easy access across the creek still feel the pinch of rerouted vehicles. The hope for a definitive scientific explanation has largely faded from the public consciousness in Havenwood, replaced by a weary acceptance of the unexplainable. Yet, the bridge's mystery hasn't entirely vanished from the scientific community's radar. It's become an informal case study, a known problem site. Researchers occasionally visit, often independently or with limited private funding, bringing new prototypes of sensors or testing new hypotheses. But so far, none have reported a breakthrough. The core problem remains. The phenomenon is localized, reproducible, though variable, affects complex electronics, and leaves no detectable trace that current scientific instruments can reliably measure or analyze. It doesn't fit the profile of a simple EM field, magnetic anomaly, structural resonance, or geological emission as currently understood. It's too specific in its targets, operating electronics, and too elusive in its signature. The official stance from the state's engineering department is that the cause is unknown and currently unmeasurable with available technology, recommending caution and adherence to the posted warnings. There's no ongoing, large-scale government-funded investigation because, frankly, nobody knows what to investigate for or how to even begin measuring it effectively. The bridge serves as a physical embodiment of a scientific limit. It highlights the possibility that there are forces or interactions in the environment that our current understanding of physics or our current sensor technology simply aren't equipped to detect or interpret, especially when those forces interact in complex ways with the intricate, low-power digital processes that define modern electronics. Could it be a strange, localized quantum effect magnified somehow? A resonance with the fundamental operational frequencies of silicon chips? A form of energy or field that interacts with information processing itself, rather than just electrical current or physical matter? These are questions that veer into the speculative, pushing the boundaries of current scientific paradigms. The Oakhaven Bridge, quiet and unassuming, continues to pose these profound questions simply by existing and consistently disabling our most advanced personal technologies. It's a place where the digital world abruptly ceases to function, where the convenience and connectivity we rely on daily are stripped away, leaving you momentarily isolated with your thoughts and the hum of your non-electronic vehicle. For the engineers who grappled with it, the bridge is a source of ongoing frustration and intellectual humility. It's a reminder that despite the incredible progress in understanding the universe, there are still fundamental mysteries lurking in plain sight, sometimes right in our own backyards. The Oakhaven Bridge over Willow Creek remains a silent, concrete monument to an unsolved modern mystery, a place where all electronics die, and the reason why continues to elude every attempt at explanation. Its peculiar nature ensures it remains a topic of hushed conversation, a local oddity, and a scientific enigma. Proof that sometimes the most baffling phenomena are the ones we literally drive over every single day. And until someone, somewhere has a radical new idea or develops entirely new sensing capabilities, the Oakhaven Bridge will hold its secrets, disrupting our devices and challenging our understanding of the world. One car, one phone, one crossing at a time. The engineers are still stumped, and the bridge, indifferent to their efforts, simply continues to do